Okay, I think we'll kick off. Welcome everybody. It's really great to see the number of people who have joined us today. My name is Paula Aisthorpe. I'm the Chief Meteorological Officer here at the Civil Aviation Authority of New Zealand. As many of you may have heard, we were hoping to have our annual MET symposium on aviation meteorology this year, but unfortunately we haven't been able to return to our usual Asteron office just yet. So we have postponed the symposium to sometime early next year and instead hosting this webinar. So this is our first go at this. So please forgive us any teething issues, but we've had a practice, fairly confident. So if you've not been involved in one of these Teams webinars before, you may notice that the video and microphone options are automatically turned off for you. So this is one of the functions of a webinar versus a normal Teams meeting. We've also turned off the chat to instead encourage you to use the Q&A function. So hopefully you are able to see that. Alternatively, at the end of a presentation, feel free to raise your virtual hand and we can then turn on your microphone. Be aware, because we're recording this and we will make it available on the CAA website later, it does mean if you're keen to ask questions, it becomes part of the recording. So just for your information there. Okay, so we have a few speakers lined up today, which is fantastic. We will be kicking off with Brad Scott, who may be a familiar name to many of you. Brad's a GNS science volcanologist with lots of experience around communicating information on volcanic activity. So he'll take you through the GNS process on that. And then we're lucky to have one of the VAC Wellington meteorologists join us. So that's Sylvia Martino, and she'll talk about what the VAC goes through, the processes they go through in sharing information on where the volcanic ash that is emitted during a volcanic eruption, how that information is shared. Then we have Hamish McCoy from the CAA, who's one of our senior technical specialists. He'll have a presentation on volcanic activity and airspace and what the implications are there when the volcanoes enter unrest and eruption. And then I'll take you through some of the upcoming volcanic hazard information changes that are coming in Annex 3. So just to give you an idea of what you might see in the future. So I will stop sharing that screen now and I will invite Brad to please, Brad, if you can share your screen, and I'll let you know when I can see it from my end. Beautiful. Thanks, Brad.
Thanks, Paula. Good morning, everybody. And as Paula said, yeah, Brad Scott from GNS. Apologise for my croaky voice. I've been a victim of COVID and just coming out of the back end of that, so I might cough and splutter a little bit through this. Yeah, so what I'm talking about today is from the GNS Science Volcano Monitoring Group's perspective and how we deal with the volcano stuff. And my first fail, it won't advance. There we go. Okay, just to set the scene, Volcano 101, we have 3 different types of volcano in New Zealand that we like to, well, we classify them into 3 groups. The first is the volcanic field. That's basically Auckland is our best example. Eruptions from there are very rare. They're small and they're localized. They will be a significant problem because they're going to be in the middle of a large city. And the real sting in the tail is we don't know where the next one will be because they're always in a new location. The other style of volcano that New Zealand is quite famous for is our caldera volcanoes. Again, these are quite rare. We're talking about return periods over 1,000 years. But when they do occur, the eruptions are large. And they do have really long lead-in times. Volcanic unrest can last for years, if not decades, before one of those volcanoes erupts. However, the one that we're likely to meet on our watch, this is the cone volcano, and that's what most people perceive as a volcano. So we're talking about the likes of Tongariro, Ruapehu, Taranaki, Ngauruhoe's, Prakari, White Island, the sort of classical, steep-sided, pointy volcano with a crater in the summit. And one of the byproducts of these eruptions, which occur frequently, we're talking about something, in the 5 to 10 year return period, sometimes more frequently, they do produce volcanic ash, and that's really the focus of today. Now, eruption size, in volcanology, we have many sizes of volcanic eruption, and they go across several orders of magnitude. So we could be talking about 0.001 of a cubic kilometre or 0.1 of a cubic kilometre, 1 cubic kilometre. We then can get to the calderas, we start talking about 5, 10, or 50 cubic kilometres, and if we get up to a super eruption, we start talking 500 or 1,000 cubic kilometres of material involved. So an enormous range, but we're really talking about down the bottom end. And of course, the amount of ash around and the effects will vary. On the right-hand side, sort of schematically showing some relatively well-known eruptions. Down the bottom is Ruapehu 95, 96. As cone volcanoes go in New Zealand, that's a moderately large and big eruption, or eruption episode. It lasted for a few months. Mount St. Helens, 1980, many people would know of in America. Tarawera, 1886. That's a 1 cubic kilometre event, just to calibrate you. Ruapehu was 0.01 in total over the sort of 6 or 7 months. And then Taupo 232 AD, for example, was 50 cubic K, and Taupo 26,500 years ago, or Oronui, was up in the 500, 700 cubic K size. So, yeah, a great variety of sizes can come from our volcanoes. Okay, eruption hazards. There are multiple hazards associated with volcanoes. There are different timescales. Some occur over just a few seconds, like during an explosion. Others last for hours. And the geographical distributions are quite varied depending on whether they're terrestrial or airborne hazards. So some can be controlled by valleys, others are going to be controlled by wind direction. And these pose all sorts of different threats to the community. If you're reading up on volcanoes, you'll probably come across discussion of near source hazards. These are typically destructive. They might be something like ballistics or lava flows. And then we also talk about distal hazards, and that's the volcanic ash plumes and ash fall or fallout from those plumes. Okay, so coming back to us, what I'm talking about here is kind of 40 years plus experience. It's a communications framework that we've developed with the many agencies that we're involved with across the volcano spectrum. It's based on no really sustained eruptions. We've had nothing that's lasted for 1 to 5 years, or like Narahoe was in the 60s or 50s, 60s, and 70s, early 70s. We haven't had sustained activity like that onshore affecting us. There's been sort of 8, single event eruptions that are over in just a few hours, typically. So looking over on the right-hand side, we'll be looking at a part of this diagram. The blue part at the top is basically our data capture. Those are all the bits that sort of come together for us to collect information and monitor the volcanoes. That moves into the volcano team in the centre there, based around a volcano science advisor, the information specialist, and the public information. And then out on the right-hand side is where we're heading today. We're looking at the use of volcanic alert levels, the VONA, volcanic alert bulletins, ashfall predictions, and those going, how can you access those? How are they available? So, the web page, social media, email type environments, information going to responding agencies, and the GNet app, which today most of us receive everything on our hip. So we'll be sort of moving down through that lattice work on the right-hand side there. So first off, the New Zealand Volcanic Alert Level System, or known as VAL. This is our key communication tool. This is how we inform everybody, from the general public up through responding agencies to the Parliament, Prime Minister's office sort of thing. What is the current status of our volcanoes? So it's one system for all of our volcanoes in New Zealand, which is a challenge when you've got all those volcano types. It's based on the currently occurring phenomena, so it's about what the volcano is doing now. It is not predictive. We do give some indications of the likely hazards in the right-hand column there. So if we say we're at volcanic alert level 1 or 2 or 3, there's some information sort of pointing you towards the type of hazards that may be associated with that. We have 2 levels of unrest. So a volcano that's quiescent is 0. A volcano that's showing some unrest will be level 1, and then moderate to heightened unrest is bundled together. That's a very deliberate move, and that's a reflection of the state of the volcanology science, not just here in New Zealand, but globally. We haven't matured enough basically to be able to separate moderate and heightened, hence we bundle them together. And then we have 3 levels of eruption, which is basically small, medium, and large. And if you look in the likely hazards column, you'll see that a minor eruption or a small eruption, the hazards are near the vent. So we're talking about near the vent, and this is dimensionless. So in the case of a volcano like Ngātahoe, we're talking about 100 odd meters and near the vent, a couple of 100 meters from it at the summit. If it was a caldera volcano like Taupo or Rotorua, we could be talking about a vent that's 5, 10, 15 kilometers across. And then we talk about moderate eruption where the hazards are on and near the volcano. So we've moved from the vent, we've looking at the whole volcano being impacted, or even areas slightly beyond it. And a major eruption, that's when the hazards extend well beyond the volcano. That's just giving you an introduction. There's a lot of information down the bottom there that's leading you further. And there's, as I say, there's more information there, indicative things to learn about. Okay, so what have we got in our toolbox? So first up, we've got a volcano monitoring program. This is funded by EQC. It's known as GeoNet. We operate the NGMC as part of that, the National Geophysical Monitoring Centre. It's a 24/7 centre, primarily set up around tsunami warning, but also looks at earthquake, landslide, and volcano. The volcanic alert level system, which we've just touched on, is our primary communication tool. The aviation colour code, which our colleagues from CAA will delve into a little bit deeper. We set the volcanic aviation colour code, and we also set the volcanic alert level through a contractual obligation with NEMA. We communicate all this through volcano activity bulletins, the VABs. This is on an as-needed basis. We produce ashfall predictions. This is collaborative with Met Service. And here we're talking about the material that has fallen out of the ash plume, not the residual material that's still in the atmosphere that you may meet while flying, but you may well meet the ash fall when you come back to the airport or the airport you're heading to. We put our stuff out through media releases, interaction with the media, web pages, and social media. And we'll delve down into 2 or 3 of these in a little bit more depth. So as I say, our primary communication tool is our Volcano Activity Bulletin, affectionately known as VAB. It's talking about the current volcanic alert level, current VAL, and the current aviation code. Those are in the header bar at the top. Each bulletin has a number for the volcano and the year. So the example there from a couple of weeks ago, Ruapehu 2023-06. So that's bulletin number 6 for 2023 on Mount Ruapehu. And it's got the date and time that it's issued, and it's got the volcanic alert level. In this case, it was remaining at 1, and aviation colour code was remaining in green. It would also state if it had gone up to level 2 or come down from 2 or something like that. But it states what the direction of that status is. If we have any sort of indications of predictions or changes in activity where we think activity is increasing, decreasing, we'll talk about that within the volcanic alert level bulletin. We'll highlight current or developing or expected problems. We may have a lot of gas coming out of the volcano. We've got a front approaching that's going to end up in an acid rain environment, or maybe remobilization, washing material off the country into streams and rivers. Distribution, we have a dedicated email list. You can contact us, myself or Paul, to get put on that list. They're on our webpage, the GNet webpage. We push notifications out through things like Twitter and Facebook. And if you subscribe to the GNet app, you can have a notification sent to the app that there's a new volcanic alert bulletin. Volcanic activity bulletin. Now, one of our special bulletins during an eruptive episode is an ashfall prediction. So it's issued as a VAB. It would just be the next VAB in the sequence, but it would be primarily dedicated to showing you the volcanic ashfall. As I say, we do not show dispersion. What's left in the atmosphere, that's up to the VAC, and there's other presenters. I think Sylvia will be talking about that soon. Now, these are predictions, so there are limitations, and they're produced collaboratively between ourselves and the New Zealand Met Service. Because it's a VAB, it goes out through that same distribution system. Now, on the right-hand side there, I have just shown 2 models. One is from this morning, 7 o'clock, for an eruption at Mount Ruapehu. And this is showing the expected ashfall over the next 12 hours. The one on the right is a ashfall prediction from Taranaki, and that was from an eruption, or from the weather system that was present on the 30th of November. And I've just used that one because it was a nice wind direction that was distributing the plume right across the North Island. The sort of hazy, particularly in the Ruapehu one today, you'll see it's got a very sharp top boundary and a hazy bottom boundary, and that's because during the 12-hour, there's a 12-hour one. During that 12 hours, the wind has been shifting, and so the wind direction is changing through the 12 hours. So the direction of the plume has changed during that period, and that's part of the understanding of the limitations of these predictions. So it sort of depends where we are in the 12-hour window as to which part of that plume you may be under and which part of the ashfall could be occurring. Now, complementing those products, there's a whole raft of information out there about infrastructure, ashfall impacts, management of ash, and volcanic hazards in general. The volcanology community globally, we've got together, and the USGS hosts it for us, is an encyclopedia of volcanic ash impacts at this website. If you just Google volcanic ash USGS, it should be the top of your Google search. There's a raft of booklets. There's 3 there from IVHHN, the International Volcano Health Network, on dealing with volcano health. On the right-hand side are some of our ashfall impact posters. We've had many students working on volcanic ashfall impacts, and we distill their theses down into these sort of A3 size single page posters, showing one there for airport operations, urban cleanup, wastewater, roading networks. There's about 13 or 14 in the series, generators and HVACs and all sorts of things that we've had students do work on. So there's a whole raft of information. And as an operator, some of your problems may well be that on the ground with your infrastructure, rather than actually while flying. And just to summarize, what are we all about? So what do we do in business as usual? The Volcano Monitoring Group, we monitor the volcanoes. It's a 24/7 process with the NGMC and our volcano duty officers. We're assessing the status of the volcanoes. We set the volcanic alert level. We also set the aviation colour code. That information and the status of the volcano is issued in our update VABs. They're on a as appropriate basis. They may come out, once an hour when we're busy, and maybe once every month or other month if we're not, depending on what the volcano is up to. We participate in a whole raft of volcano advisory groups. On that sort of family tree diagram, I didn't mention them, but down on the left-hand side, there's volcanic advisory groups for calderas, for Auckland, the Central Plateau, Taranaki, etc. So we have a lot of engagement, with NEMA, the CDM lifelines, etc. through those. We're very involved with the VAC, and we do volcanic research. When we go into our response mode, it's pretty much the same. We're assessing the status of the active volcano. We're looking at the volcanic alert level and aviation colour codes. We issue VONA when the aviation colour code is changed, the ACC. That is accompanied by a VONA. That is distributed to Airways and onto you guys through their networks. You will see on our VAB that the aviation colour code has changed, but we don't distribute publicly the VONA. We'll be issuing lots of updated VABs. We'll be issuing ashfall forecasts, working with the BAC on updates on the status of the volcano, and doing a whole pile of communicating with people and agencies. And we undertake opportunistic research because it's only when an eruption occurs we learn about them. So thanks very much for coming along. I'll pass back to Paula.
Thank you so much, Brad, and thank you for pushing through the after effects of COVID. It's really awesome of you to be able to still present. Thank you. Now I see some thumbs up but no hands up. So if there's no questions, please do use the Q&A. I've popped some links from Brad's presentation into the Q&A just so you can click on them in there. And so for the USGS site that Brad mentioned, I've got also a link to the colour codes so you can learn a bit more about them. And also there's some fantastic resources on the GNS website, so there's a link there as well. Okay, thanks again, Brad, and I will now invite Sylvia. I will let you know when I can see your screen.
Cool. Can you hear me?
I can hear you. Yep.
Oh, that's a good start.
Just seeing a black screen at the moment.
Just thinking about it. All right.
Right, there we go.
Is that working?
Perfect. Thanks, Sylvia.
All right. So, hi everyone. I'm one of the aviation forecasters at Met Service, which means I also take turns looking after our VAC monitoring. So we're one of the volcanic ash advisory centres. We cover a big swathe of the Pacific. Today I'm mostly talking about our process over New Zealand, since that's what you're most likely to engage with us in, but it's pretty similar over the ocean. All right. So we get notified of an eruption in New Zealand. That usually comes to us from GNS, but it could be a pilot report, it could be a local observation. We might see it on webcam, satellite, or our radar systems, and we'll get in touch with GNS to confirm an eruption's happened. Once we have confirmation of volcanic ash, Then we start with an initial VA SIGMET, and I'm just going to run quickly through the process, and then we'll go into more detail about what each of these steps takes. So the goal is to get that initial VA SIGMET out within 5 minutes of confirmation of ash being present. Then we go to an initial volcanic ash advisory and the graphical product that goes with that 5 minutes later. The full volcanic ash advisory, which has a lot more information, 30 minutes later. And finally, a full VA SIGMET. And then we keep reissuing these every 6 hours or if any information changes. So to start off with, first thing we get out, our initial VA SIGMET. Minimal information. The point here is just to let people know that an eruption is happening. So all it says, VA eruption, it'll give you the volcano with its position, and it'll say volcanic ash cloud is observed. It'll give you the time that it was observed and repeat the position. If the ash cloud had a different position, it would be in there. If we get, oh yes, there we go, position, time of observation. If we get a height estimate with the initial observation, we'll put that in. So here, surface to flight level 100. But that's only if someone's told us. So if GNS have given us an estimate of the height, if our radar system or satellite has a quick estimate, if a pilot report has told us a height, we'll put that in. But at this point, we're not stopping to work anything out. We're making sure that we get that initial information out as soon as possible. And that's what it looks like on the graphical SIGMET monitor. You can't really see it on this tiny one, but there's no information in that little box beyond refer to the volcanic ash advisory for more information. So it's really just letting you know something has started to happen. Right, then we move on to the initial volcanic ash advisory, which looks like this. A lot of text. So if we run through that, it's got the same information about the volcano, position, name of the volcano, the area that it's in. Now, if there was a new volcano popping up, it would be listed as unknown. If we had a position, we'd put that in. Otherwise, the position might also say unknown. We come down to our info source. That's going to tell you how we found out about the eruption and how we're getting the information that's in this VAA. So that source could be GNS, it could be the Himawari 8 satellite, it could be a webcam, it could be a pilot report, and so on. The aviation color code, if GNS has passed one on to us already, we'll enter it there. Otherwise, it will just say unknown until the point that we get that update from GNS. Eruption details, if we have any, we'll put them in, but at this stage, it's likely to say more information to follow because, again, we're just trying to get this out within the first 10 minutes to give you the information about ash that's present. So then we get on to this observed VA section. So it gives you time of issue, our best estimate of the height at that point, and then a position. So if we can see a VA cloud on our satellite imagery, or based on another observation like a webcam, then we'll draw on where we're seeing the observed cloud and a movement. If we can work that out from wind observations nearby, there's an emphasis on speed, so those estimates might change when the full VAA comes out roughly 20 minutes later. And if it's not identifiable, if there's met cloud over the top, if we can't see it clearly on satellite or webcam, it might say VA cloud not identifiable, but we still want to get the information out. If you see down the bottom, there's a remarks section, and so we'd note something like met cloud obscuring the area. Then this forecast VA area, well, let's see if it's going to do that. Yep, there we go. So you see this forecast cloud for 6 hours, 12 hours, 18 hours, says not available for now. That will come in the full issue. That's the next thing to come out. For now, it's just, here's the ash, here's its basic movement. And then there's information on when the next advisory will be. In graphical form, that looks like this. So on the top left, we've got the observation. There's a box showing you roughly where the volcanic ash cloud has been observed. And then top right is 6 hours, bottom left 12 hours, bottom right 18 hours, and those are all blank for now because we don't yet have the forecast information. And below those graphical panels, you've got the same information listed below. You can see this one's just saying test, 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 because that was a test volcano. Then we move on to our full volcanic ash advisory, and we're still trying to get this out quickly, but we're taking a bit more time to run through the modeling and whatever observations we have so that we can get more information out. So our modeling of ash dispersion, just a quick look at it. So we run a model called high split. Here's a quick look at its output. So the columns are 3 different models. The rows are different time steps, and we can do small, medium, and large eruptions. If we have any eruption details, the duration, how long it's been going, the height, we can put that in. Otherwise, we've got a set of standard small, medium, large parameters that have been given to us. And so we run those through. We don't look at these tiny charts. We look at something more like this. So we've got different colors showing us the heights that ash is reaching. This is probably a time step quite a bit further on from the initial eruption. So it's showing us where the ash has gotten to. And you can see in this case that we've got quite different directions in this pinky purple going out north, northwest, west, northwest. So that's more what the surface wind will be doing. And then the higher colors of ash heading out east, southeast with the upper winds. We get this output for different models and the different sizes of eruption. So we can run through, look at that at different time steps and decide which looks most convincing. So we're looking at the model performance, especially with respect to the wind field, because obviously that's going to make the biggest difference as to where the plume ends up. So we'll be looking at current observations, we'll be looking at how the models have been performing that day, and we'll choose the most likely scenario. Then we get to the full VAA. It looks very much like the first one. We'll fill in any extra information we have. So if we've received the color code, that will go in there. If we've got more information about how we're observing it, that will go in there. We'll have a better estimate of the height. So we'll have used satellite data, radar data, webcam, if possible, to get a good estimate of the height. If we can't see it, then that will come out of the model estimates. So it will say estimated instead of observed. And then we've got the current ash position at the time of this full VAA being issued. So that might be slightly different from the initial one. And then these forecast ones for 6 hours, 12 hours, 18 hours. So you've got a position, you've got heights, and you've got movement. And here we go. So same thing for the VAG. Now we've got 6 hours, the observed 6 hours, 12 hours, 18 hours with a polygon showing you where the volcanic ash is expected to be and the heights on that. Now, in this case, all the heights are the same. We could have multiple polygons showing us different heights, like in that last example where the low-level ash was off to the west, the higher level stuff was to the east. So we might need to have multiple boxes on there, and we're going to see what that does in the next one, which is our VA SIGMET. So the full VA SIGMET comes after we've done that full VAA. We import the information from it to make sure that everything is in agreement. Here it is, looks much like the last SIGMET, except that we've got a lot more information in there. So we've got, yep, we've got the observation. So that's the points in which it was observed, mapping out that polygon. It's got the height on it. So in this case, we've got surface to flight level 350. Now, when, there we go to the 6 hour one, it'll show you the new position. Note, it doesn't show you a new height, and that's because our heights have to match at the start and the end. So if we do have different heights, we'll be issuing multiple SIGMETs for all the different heights that we have. Okay, then here's the GSM. Doesn't have any more information than our initial one. It just shows you which volcano has erupted, and it says refer back to the VAA and to the full text of the SIGMET. There we go, zoomed in. So yes, doesn't give you anything on the graphical one. You do need to go back to the text-based forecast. And then what do? Well, we continue monitoring, so we were watching very closely, satellite, radar, webcams, checking for observations from the public. We're communicating with GNS, with Airways to make sure a NOTAM gets issued as soon as possible, with CAA, anyone else. And we reissue the VAA and the VA SIGMET every 6 hours, or more frequently if something significant changes. And that keeps going until there's no more significant ash observed. And that's me.
Awesome. Thank you so much, Sylvia. That's really great to see that process that you guys go through. Clearly a lot of work when those volcanoes first send ash out into the atmosphere. There's a lot to get underway. So I don't see hands up. So again, please do use that Q&A function if you have any questions on the process that Sylvia's outlined there. If you want to see examples of volcanic ash advisories, real ones at the moment, you can go to the VAC website, which is vac.metservice.com. And there's actually, even though there's not necessarily any in the VAC Wellington region, there are links to other VACs on each VAC website. So you can see what's happening in other parts of the world as well and get an idea of the sorts of events currently underway. Thanks again, Sylvia. So I will now see if Hamish is ready and get Hamish to share his screen. So Sylvia, you can stop sharing now.
It told me it was going to cancel it for everyone, so just see what happens if Hamish tries to take over.
All right. All right, looks like we're good. Thanks, Sylvia. And thanks, Hamish. Looks good.
Okay, can you guys see my screen, Paula?
Yep, all good to go.
Great, okay, kia ora everyone. So my name's Hamish McCoy, I'm with the CAA, and for those of you I don't know, I recognise a few names on the list there, but I work in the Aeronautical Services Unit at CAA, so we're responsible for designating airspace in New Zealand, the regulation of sort of aeronautical information, airports, air traffic control, technology, all sorts of things like that. But today I thought it'd be really useful to have a talk about volcanic hazard zones in New Zealand, which are quite a unique sort of piece of airspace. So hopefully, this is sort of just an introduction, but hopefully it gives everyone sort of a little bit of a rundown. So I'll just wait for there we go. Okay, so volcanic hazard zones, what are they, where are they, why do we have them? Being a good regulator, I have to sort of have a rules reference in here. So we have Rule Part 71, which talks about how we can designate airspace in New Zealand, and one of those pieces of airspace is volcanic hazard zones. And you can see there that we may do it for, you know, if there's areas of volcanic activity, such as rocks, gas plumes, ash clouds, that may be a hazard to aircraft. So the important thing here is, well, a few things. One is that they're actually unique to New Zealand. So they're not MICAO designated airspace under the annexes and so on. And they were originally set up in the 1990s, and that's why I've put a picture there of Mount Ruapehu in 95, 96, and it was post Ruapehu that they decided at the time that volcanic hazard zones could add some benefit to the aviation system where there's an immediate hazard to aircraft. So you might be asking, why do we have these when we also have things like VAAs and SIGMETs and VONAs in the modern system? And one of the answers is that they do protect aircraft from the immediate hazard. So as I'll talk about a little bit later, they don't necessarily protect from the wider ash cloud that will develop, like Sylvia has talked about, but they potentially could protect an aircraft for an immediate an eruption. So we have 5 permanent volcanic hazard zones in New Zealand, mainly around the Central Plateau, White Island and Raoul Island. and they have been in the AIPNZ where they're published, and they're published on the charts as well for pilots. So as Brad alluded to, we use the volcanic alert level system in New Zealand. So on the left there, you can see that as Brad has presented, and on the right is how we determine changes to volcanic hazard zone sizes based on that alert level system in New Zealand. So you can see that's an extract from the AIP, and what we do is where it's obviously, as you go through 0 or 1, the radius from the event will be 3 miles. And then as it goes up from there, up to alert level 5, where it's up to a 50-mile radius up to flight level 660. So obviously it's a 6-level system. And the size and the scale of the event, may vary from volcano to volcano. So, for example, a level 3 event at Ruapehu may be different from a level 3 at Ngārahoe, or for different types of volcanoes. So I'll talk a little bit more about that in terms of some of the challenges we have around that. But the volcanic alert level issued by GNS is an important trigger in the issue of a NOTAM. So what happens is if a volcano goes up an alert level, and there is a permanent volcanic hazard zone around it. So if we take Ruapehu, for example, then a NOTAM will be issued by the NOTAM office that says, it's now at alert level 2 or 3, etc. So here is an example, and this is actually taken from, I don't know how many of you may have attended the volcanic exercise earlier in the year that Paula set up. It was a fantastic exercise where we simulated an eruption of Mount Taranaki, and it was a great way to practice how the aviation system might respond to a volcanic event, particularly in a area which has recently been a dormant sort of volcano, I guess you could say. So with this example, you can see on the left there, we actually put out a NOTAM for a temporary volcanic hazard zone. So the CAA may designate temporary volcanic hazard zones if needed for a new area of volcanic activity. And for the purposes of the exercise, we thought it would be beneficial for a few reasons. One was to see how the system responded, but also to see, well, with all of these other tools we have, VAAs and VONAs and SIGMETs, etc., how useful is a volcanic hazard zone in this modern environment? So you can see there that on the right we have depicted through Google Earth and on the Airways surveillance screen, Taranaki's at alert level 4 at that point. And what actually happened through the exercise is, well, you can see there's quite a few IFR routes impacted there, which are in yellow. And Airways actually assess a lot of these routes, and they can provide assistance to stay clear of a volcanic hazard zone in these sorts of scenarios if an aircraft is under radar or surveillance. So there was, through the exercise, some benefit, at least from that perspective, in having a volcanic hazard zone temporarily set up for the exercise. The output of this exercise was in the form of a report, which Paula has actually just finalised. So if you'd like some more information on that and you didn't manage to attend earlier in the year, she does have that available. Some really, really good learnings and recommendations around how we're managing airspace. So the CAA is required to conduct reviews of airspace, and in 2024, 2025, we have a plan to conduct a review for volcanic hazard zones. And one of the aspects well, the main thing that we will be considering is, whether what we have is suitable and make sure that we can manage the aviation risk appropriately with volcanic hazard zone in New Zealand. So this doesn't necessarily mean that we'll change anything. It just means that we'll be working with all of our stakeholders, GNS and Met Service, and all of the operators in New Zealand to develop any review of changes. So, just asking the question, what do we have? Is it suitable? Are there any changes we can make, etc.? So I've put up this here because this shows the volcanic alert level dimensions, and then an arrow pointing down to the aviation colour code. So one of the questions that we've asked recently as well, why do we use the volcanic alert level for volcanic hazard zones when we could use, for example, the aviation colour code, which is an ICAO colour code? And it one of the reasons for this, and I've put up a picture on the right of Lake Taupo. So, for example, earlier in the year, Taupo actually went up to alert level 1 due to some seismic activity. Zero risk to aviation. But, I mean, for example, if that was to go up to level 2, would we need to designate a temporary volcanic hazard zone around that area when there's no risk to aviation? Same with another volcano, if it already had a volcanic hazard zone around it. If it went up to a higher alert level, doesn't necessarily equate to the aviation risk as such. So that's one of the questions we are asking is, okay, so would the colour code be a more suitable alternative to the alert level in determining volcanic hazard zone size and dimensions to protect the aircraft from the risk? So we'll watch this space as we go through the review process, and if anyone is interested, we'll certainly be consulting on all of that in due course as well. So I've been asked to talk about a little bit what are the implications of these things for pilots. So the practical sort of implementation of this. So once again, as a good regulator, Part 91 determines what pilots can and cannot do in volcanic hazard zones. They can be reasonably restrictive, as a lot of you will know from flying around the country. And the main thing is you need to be able to see what sort of hazard you may be approaching. So if you can't enter during the night or IMC, and it must be in obviously VMC, and you must obviously take into account all the MET and NOTAM information. So you'll see on the right there, I've put up an interesting thing that pilots may need to consider, especially flying IFR and particularly around the Central Plateau. So on the right, this is a procedure an instrument flight procedure that goes into Taupo, and IFR route designs in New Zealand do not take into account volcanic hazard zones for a few reasons. One of which is that they can obviously change in size, and this is actually a star into Taupo, and you can, for those of you that know what these charts look like, you can see the minimum altitude on that particular procedure is 6,500 feet. Whereas right next to it are the Ruapehu and Ngauruhoe volcanic hazard zones up to 9,500 and 10,500 feet respectively. So pilots need to take that into account in their sort of flight planning, and in particular where there may be a NOTAM out. Like I said before, airways may provide information to stay clear of the area, and that'll obviously be determined on whether you're within radar coverage or not, or within controlled airspace in particular. So make sure you check your NOTAMs to stay up to date, particularly for any changes in size. So this information about encountering volcanic activity is partially from our GAP booklet, which I'll share a link to at the end, which Paula has put an enormous amount of work into updating recently. So what do you do if you encounter volcanic activity? So sounds reasonably common sense. If you do, exit as quickly as possible. The overall recommendation is, if you're in flight, a descending 180-degree turn ideally is great. The reason it is suggested not to climb is because often you'll be climbing into an ash layer that could be above you. And the other thing is, when you're en route in particular, make sure you pass any report onto Airways if you see anything. The other thing we do have is once you land, if you do encounter anything that isn't already NOTAM'd or in the aviation system at all, is fill out a volcanic activity report. So this is a CAA form, and I've put a link here to the form as well. And then you can pass it on to Met Service. And as Sylvia said before, that can really help Met Service in determining how they are promulgating any of their information to inform other pilots in the system. So it's really, really helpful if you do so. So another point about accessing information, I've mentioned NOTAMs before, and this is just something I pulled yesterday actually on White Island. So you can see on the left there, we have a NOTAM currently out for White Island Volcanic Hazard Zone. So it's currently at alert level 2. So the radius is increased and it's up to flight level 150. On the right, this is just a snip I've taken from an online platform called Preflight, which is an absolutely fantastic tool that has been developed by Aeropath. If you haven't used it, I really, really suggest having a look. It's a great tool, and it shows a lot of up-to-date hazards, and you can see them in a spatial context. So you can see White Island Volcanic Hazard Zone there, and the expanded size. So really, really useful tool in terms of your flight planning for these in the system. CAA has a lot of educational material on flying around volcanoes. I mentioned the GAP booklet, which Paula and the CAA team have been working on over the last couple of years or so, is absolutely fantastic tool now. And there's also a whole section on the CAA website about volcanic hazards. I've put the links up there. If anyone would like the presentation, I'm happy to forward it to you. There is a lot of stuff out there, and yeah, watch the space for the upcoming review of our volcanic hazard zone airspace. And that's me. Thank you. If anyone has any questions, I'm happy to take any.
Thanks so much, Hamish. I have popped a link in the Q&A to the volcanic hazards site you've got there, so everyone in the audience will be able to click on that to reach all those resources there. And hopefully by the end of today, we'll have the Taranaki exercise report on that site as well. So if you want to have a look through that report, as Hamish said, we had a fantastic time going through it all and coming up with lots of what if scenarios, and so there's some excellent lessons that have come out of that we'll look forward to progressing the actions and recommendations over the next year or so. I don't see any hands, so thanks again, Hamish. Really appreciate that. And I will share my screen for the last presentation for this webinar. Okay. Hopefully that showed up. So what I'm going to take you through is just some of the new information and services under the ICAO system that are in the pipeline and coming through. So first one being the elevation of the VONA. So you've heard the VONA mentioned a couple of times during this webinar. So this is the Volcano Observatory Notice to Aviation. So this is the aviation specific piece of information that's globally consistent. And currently ICAO Annex 3 requires that to be sent to in New Zealand to Met Service and to Airways. So it's not something that's widely shared. However, there is an email distribution of the VONA. So it does go out to more than just Airways and Met Service, but the plan is to make it available to everyone, just like any other piece of Met information within the aviation system. And also just talk a little bit about what's happening with the quantitative volcanic ash concentration information. It's a bit of a mouthful. So now, you may have seen this slide a couple of years ago. The intention was in 2023, the VONA was going to be elevated to be a recommended practice by volcano observatories to then be able to make this information available through the aviation system. It got delayed to 2024 through for various reasons. And unfortunately, in the last couple of weeks, we've heard it's now going to be 2025. So in 2025, unfortunately, still a couple of years away, The VONA is anticipated to become a product that will be available to everybody within the aviation system. It means that there's, particularly for international flights, there'll be a source of information that's globally consistent. For route planning, you'll be able to know what the status is of the volcanoes underneath that route that's being planned. It may be worth mentioning as a meantime, you may have seen the odd volcanic ash advisory come from VAC Wellington for when there's actually no ash being observed, but there is significant unrest. And that's something that VAC Wellington has done on occasion to get that information out into the aviation system for some of the Pacific volcanoes that are less well monitored, or communication is still perhaps not where it could be. And so the volcanic ash advisories will, on the odd occasion, to for new activity that may not previously be known, there may be a VAA issued for unrest, but the VONA is where it should be at, and that's also where it's going to be at going forward. And so you'll see it in anywhere that you would see any other hazardous met information, like SIGMETs and volcanic ash advisories. So that's the plan, 2025. So if we have a look at what would currently be on, for example, the GNZ SIG weather on pre-flight, when you can see the hazardous weather information, you would see for any volcanic alert level 2 or higher, you'll see a marker. And so that's the current system, but perhaps in the future, when all the volcanoes have a colour code and are promulgated through the VONA, you might see something more like this, if this is how it would be chosen to be displayed, where the volcanoes that are monitored across New Zealand all have their colour code, and then there may be some others that show up. And this little box is for rail out further into the ocean. So as part of this VONA elevation, we actually have a new colour code, which I guess is grey, and this is what we're calling unassigned. So this is for those volcanoes where there's just not enough information available to assess what the current status of the volcano is. So this is a typical one, would be for undersea volcanoes. The Volcano Observatory can't tell you that it's green because they just don't know. You might know that if it reaches yellow or orange due to observable activity like pumice rafts or potentially steam eruptions, or maybe in extreme cases a whole new volcano forming out of the ocean, as we've seen in recent years with some of the Tongan volcanoes. So this will be something new that we'll see from 2025 onwards globally. And as you may know, there's actually quite a few volcanoes out there. So this is a lot of the VAC Wellington region. We do sort of squeak into other regions through here. So VAC Darwin over out further to the west. But as you can imagine, for those international routes, there are a lot of volcanoes to kind of just be aware of when planning routes. So having that awareness of the observable activity will be really important for the safety risk assessments for those flight planners. Now, also from 2025 onwards, we have the introduction of quantitative volcanic ash concentration information. So for those who have attended previous MET symposiums, you will have heard about this in the past, but just to reiterate, the idea is that instead of having a VAA or a VA SIGMET that describes an area of ash, so just a single binary piece of information that says ashes in this area and outside no ashes observed or forecast. Instead, it's going to be information on how much ash is being forecast throughout 5,000-foot layers of the atmosphere. Initially, this is just going to be provided for significant eruptions, and those eruptions are the ones that pose a widespread impact to aircraft operations and air navigation. So if it's near an international airport, if it's at a decent height across a busy flight route, so the ones that are going to really make a difference to flight operations and safety. It'll be provided in a couple of different ways. So there's a probabilistic QVA, as we call it, the quantitative volcanic ash, QVA in a gridded format. So this is like model data that a user can ingest and visualize however they like. And also what we call deterministic. So just here is our best answer to what the concentration of ash is. And this is in what we call IWIXM format. So it's a heading into the future swim compliant format, but this can be visualized in a more simple way. And the plan is eventually that QVA will be the source of information on airborne volcanic ash to eventually replace volcanic ash advisories and VA SIGMETs in X3. I say eventually, it's not going to happen soon. So here's an example of what the deterministic QVA would look like. So each of these polygons describes an increasing level of volcanic ash concentration. And this like hole here shows that there's an area that's below the minimum threshold for providing information. And this image here on the left shows an example of probabilistic QVA. So this is for somewhere between 30 to 35,000 feet. And what's the chance of the ash exceeding 0.2 milligrams per cubic meter? So that's quite an important threshold. That's roughly where you would start having a volcanic ash advisory or SIGMET show you information. Anywhere less than 0.2 milligrams per cubic meter, it's just not observable. It's very diffuse ash. So this would give operators some confidence of where the ash is most likely to be using an ensemble model. So if all the different model runs say in this area just off the coast is where the ash is going to be, you can be fairly confident that's the place you may like to avoid. So this can actually just be visualized just like a regular old volcanic ash advisory graphic if any operators aren't that interested in the concentration. If your plan is just to avoid the ash, then that is fine, and you can just avoid the whole area, and this would be equivalent to a typical volcanic ash advisory or SIGMET, where, as I say, the 0.2 milligram threshold is what you would already receive when you get your SIGMETs and volcanic ash advisories. So this very complicated looking graph here is what has prompted this work. So you may recall some of the eruptions from 2010. So that was I'll try and say the name, Eyjafjallajökull, I think is how you say it, the Icelandic volcano that sent ash right across Europe for several weeks. And then a year later, we had Puhai Koronkoye, which sent ash from Chile right around the Southern Hemisphere several times. So an extremely clever man from Rolls-Royce, Dr. Rory Clarkson, he developed what he calls the DVAC chart, or the duration of exposure versus ash concentration. So all these circles and ellipses here are either real events, such as these red ones down the bottom right-hand corner there. That's the KLM flights intersecting with the readout eruption, and Galungun, which was the Speedbird 9 BA flight. So these are obviously the safety implication ash events, encounters, and then there are others where it perhaps was a laboratory experiment, various other lower impact volcanic ash encounters. And so what Rory's done is he's managed to determine for Rolls-Royce an acceptable level of volcanic ash dose. So that was what, unfortunately, that band that was across the screen before said. So, so what this means is that for specific Rolls-Royce engines, operators can choose to fly through areas of low concentration volcanic ash for a certain amount of time, equivalent to the dose that has been declared as not having any significant safety implications. And that just means that operators can potentially choose to, instead of having to stop all operations during one of those long-lived events like we saw back in 2010, 2011, they may choose to fly through some low areas of volcanic ash concentration. So here's an example of what that might look like. This was taken from a paper that Dr. Clarkson has written on maximising airspace use during volcanic eruptions. However, the numbers have been edited to match the proposed concentration levels that will be in Amendment 81 to Annex 3. So it shows different flight routes through this fictional volcanic ash emission that has a level of that lowest concentration level. And you can see even when in this grey area, which is equivalent to the next level up of ash concentration, because it's such a short duration, it actually ends up being one of the lower doses at 4.5 grams seconds per meter cubed, and it's 14.4 grams is the dose tolerance that Rolls-Royce has declared. So you can see in all these three routes, none of them have exceeded that dose tolerance. And the advantage of that more northern route is that there is the potential to divert to City C if needed. So this is an example of how quantitative volcanic ash information could be used in the future for those really disruptive events. So just to wrap it up there, because I realise that we are over time, there are so many great resources. Some of them you've heard about already. The Flying Around Volcanoes, that's available on the CA website. The GeoNet's website has lots of information about what's currently happening at New Zealand's volcanoes. The GNS website has lots of fantastic resources. So these were all popped in the chat before. And we have on our own CA website volcanic hazards information. So I will leave it there. I realise that many of you will probably have to head off, and I will encourage you, if you have any questions, you can send them through via email. I'm just going to stop sharing now so I can see if there are any hands up. Not yet, and no Q&A. So that's fine. Please do feel free, as I say, to email met@ca.govt.nz if you want to ask any questions, and I can forward them on if needed. And I hope this has been really useful. And I thank you all for attending. And in particular, a big thank you to the presenters today, Brad and Sylvia and Hamish. I really appreciate your time. And oh, we have some new posts. Maybe we do have a new question. Ah, great. Thanks, Jason. And as I said, this will be recorded and made available on our website. So on that same volcanic hazards link on our website, that should be just under there. So yeah, thanks once again. And I look forward to hopefully bringing you some more webinars in the future, in the new year. All right. Thank you.